Well, from the lowest level possible to the highest level possible. I sincerely have to admit that when Oren started speaking about scratch file, I started scratching my head saying, And same as before. It's always me. What I like to speak about is during these days, domain-driven design and especially CQRS and event sourcing are on the mouth of everyone. Everyone is speaking about event sourcing and CQRS. And the biggest issue is that there is no magic bullet to apply CQRS and event sourcing. They are just mainly concepts, and you have to try to understand how to put them in your context and survive with that. And what I'd like to try to do today is to see what we can leverage from RavenDB in order to simplify our daily living with the CQRS and event sourcing. And we are going to use a demo, and do not take the code in the demo as a production code. It's just made for the demo. And I really like the Ekjana approach in having the mediator building the read model to give it back to the front-end application. In this demo, the code is barely written in the action of the controller, but it's just there because it's a demo. Okay? What I want to explain are the basic concepts. This is the structure of the demo that you will have on your machine if you want. It's based on an AngularJS application that is really simple. It does just 3 things and nothing else. And it uses HTTP async AJAX request to a backend server. The backend server basically does nothing. It's just a broker that handles the HTTP connection to the client and handles the other connection on a queue, in this case based on MSMQ. And the demo is based on MSMQ basically because it's the easiest way to install on your machine if you have nothing. Instead of telling you, OK, you have to download Rabbit, install Rabbit, run it as a service, it's much easier to set up MSMQ, and it just works. So the web API host simply pass through requests on the queue. And on the other side, there are a backend service that in this case is a console application that the queues requests from the queue, does stuff on the server. Basically, in this case, updates or store data using the client API of RavenDB, and sends back event on the queue, telling to the front end that the back end has done its job. And the back end now can move on because events are pushed to the AngularJS client application via SignalR. So basically, the user experience that the user can have is really similar to a monolithic application where everything is synchronous, because at the application level, we can decide how to behave. We can lock the entire page saying, OK, you have to wait. Or if it's a really fire and forget application, we can simply say to the user, OK, we are doing that stuff for you. And now you can go on and do whatever you want. And when it's finished, we'll just notify you. Just a little background about CQRS. The most interesting concept of CQRS is that reading and writing to and from the same store is the worst thing we can do. Think about store. You can think about store as in terms of shape, for example. The shape of the data you write are tremendously different from the shape of the data you need to read. Most of the time, you write a person document, and then what you have to get back is a search result that pulls out some properties of the person document, but you don't really care to have back the person document at all in that scenario. So we can say that there can be only one single source of truth that from the domain-driven design point of view is the aggregate truth, and that is our document, that is our truth, and then we can have a lot of views of the document that are the read views. If you think about it in a relational manner, you can think of it like tables and views. So we can have one table storing persons, and then a lot of create view statement that produces a lot of different shape of the same data, exactly for the context you need that data for. The interesting thing is that there are some relational databases, like Oracle, that has always had the concept of the materialized views that are eventually consistent. So basically are updated by the database engine when it can, and not in the same write transaction. And what CQRS says is that you should have as many read shape as many scenario you have. So if the same data is displayed, think about it as screens on the end user application. If the same data is displayed 10 different times, you should have 10 different classes, 10 different C# objects that represent that 10 different times, and they should be mapped to 10 different views in the database. And then there should be some sort of background engine that updates stuff and keeps stuff in sync. Obviously, that background engine is async, so you have to embrace eventual consistency. But we have learned that we have to live with it. It's a pretty good thing. So if we want to summarize it using a picture, we should have a write database. Think about database as table, database, same two different databases in the same server, two different servers. It simply doesn't matter. Another a storage for writes, and then a synchronization process that produces the read result of the written data. But do we really need hard boundaries, as in the picture before, or this picture is exactly what RavenDB does today? Because we have the document store and we have the indexing store. And we know, and if we don't know, we'll know during the session, that we can store data inside the index. And we can read directly from the index. Basically, what the indexing engine does is, at the bare minimum, say, OK, I want to index this bunch of documents. We can see an index as an hash table. And I say, OK, for this indexed data, the key of the document is this one. And what happens when we query is that we query the index, we look for the data, we retrieve the key, and then go back to the document store and load the document. But if we can put some data inside the index, what we can do is query the index, load the data from the index in the shape we need it, and get back to the user. So we can use the index itself as a read storage for the read part of CQRS. So the first thing that RavenDB offers to us in terms of CQRS is what we can call index projection, or that funny method name project fields into index results, or something like that. I do not remember. Every time I had to trust the intelligence. So as we said, the index is the primary means to look for data, and we can store data inside the index itself. Let's see it lively, that it's much better. So, second. Okay. So, Control F, tac. Start. So the console application is the backend process. Represents the Windows service that represents the backend. Then we have in the Firefox, we have the web application running. And the web application simply have a search type head that we are using the suggestion feature to suggest results and so on. And we start in a second. And we have two ways to create the two types of data the application handles that are companies and persons. So if we look for something, for example, the company I own that is called Manager Designs, as soon as we start writing with a delay of 500 milliseconds, we issue a query to the server and get back some data regarding the results. But in this case, what we can look here is that if we reduce the query to MA, we have back persons, and we have enough. Okay, there can be also companies in that result. But we are not getting back companies or person classes. What we are getting back are search results. Because basically, we are not interested in getting back companies or persons. We are not interested in this case because the application doesn't have this concept of inheritance. We do not have in the database the concept of entity and company and person inherits from entity. We have a company, a person, and then we have a search result that with a completely different concept. Why this is important? Because if you think about it in terms of bounded context, the search is a bounded context. So we can think to search as an application dedicated to let the user search for stuff in the system. And the search is totally not interested in the fact that a document represents a person or a company or an order or a product. The search is interesting in letting the user search and display something to the user. So in this case, what the search is interesting to display is that the data returned is a person, but that concept is important to the user, not to the search. And something that let the user, in this case, my name, Mauro Servienti, that let the user understand what the data is about. So how can we do that in code? Let's start from the index. One really amazing thing of RavenDB is the multimap indexes that allows to create a sort of a union in T-SQL where we can mix together data coming from different collections, even if all these collections are totally unrelated to each other. So we can create a class in this case, because I'm using C# also to define indexes. We can create a class that inherits from abstract multimap index creation task. And we are defining these two small classes where the search map is just for the IntelliSense to be happy while writing C# code, and we'll see in a minute why. And the search result is the projection that the index will store inside itself, and that will be loaded once the query is executed. So what happens is that they are just two classes. They all have private setters because they basically are never used by our code. The first one is used only by the IntelliSense, So it's only the compiler that wants it. And the second one is used only by JSON.NET while deserializing stuff. And JSON.NET happily live with private setters, and so it just works. And we need all this because we have a strongly typed language as the client language in this case. If in this case the client language would have been JavaScript, we can get rid of these small classes because JavaScript, it's so dynamic that it just works, okay? And for each type that we want to search for, we add a map to the index. So we'll tell to the indexing engine, we want you to index this type of documents. And we are going to create a document that contains a content property that will be the content where we will perform a full text search. And in the same document, we are adding the display name and the document ID, and a couple of properties that are required by how the application works to handle how to behave when the user clicks on something. It's just a technical problem. And what we emit to the index is we're not interested in emitting the fact that we have a first name and the last name, because we are just displaying data to the user. So we want to put in the index a display name, something that we can output to the end user, and is the end user that knows what's the meaning of that. So we create this shape for persons, this shape, the same shape for companies, and in the end, we are storing data into the index. So we are telling to the RavenDB indexing engine that we want that inside the index, these four properties should be stored. We are not using the store all fields method, that is a handy shortcut to achieve the same result, because we are not interested in storing the content property. The content property is just used for searching. And we are not really interested in having it back when we execute the search. From the client point of view, first of all, we have a search controller. This is just a way to highlight that we have a different context at all. We can isolate a search controller in a different DLL, and we can add a reference to the assembly that, given the way Web API works, it just works. We don't have to mess up with namespace and stuff like that. We have a dependency on the document store and nothing like that. And as soon as we issue the query, we go to the session. We queried our store using the parties search full text, that is the index we have just seen. And we are using the first parameter of the generic method. We are using the search map class. And the only need for that is that we want to write this guy using the IntelliSense and not using strings. That class exists only for that. If you want to use the advanced.Lucene query and you'd like to live with strings, you can do that without defining the search map at all. It's just there for that. This guy is just an extension method I've written in order to let the user write strings with spaces, and we split by space and search for all terms written by the user. It's just split stuff and use the Lucene syntax. Then we do some pagination. We order by score because we can define boosting on the Raven index, so we can define the importance of data depending on where we found the result. And then we do the magic. Project from index fields into this class. Because without the last line, what happens is that RavenDB do the search and then tries to return documents and not projected documents. So we'll end up in the application code with a enumerable of something that cannot be deserialized, because we do not have an inheritance tree that let us say, OK, I want to have back an higher number of particles. So we are telling Raven, OK, ignore the fact that the index entries points to a document in the document store and pull out of the document store of the index store something that will fit this shape. So basically, RavenDB is trusting us and is telling JSON.NET, OK, get the result from the index and try to deserialize it in that class. And what we have back is a denormalized projection of the data we can look for. So we do not have two different stores in reality, because we are not storing search data in a different database, but we are, from the client point of view, we are achieving exactly the same thing. We have a, well, I don't want to use perfect, but we have a pretty well-defined read model that is pulling out data from a read storage. We can simply change this code to read from a different database, and we'll see how in a, I hope we have time enough. And then we are doing some more stuff that we are suggesting and so on, but that's RavenDB code, not really the session. So with the interesting thing is that an index is bound to a collection. The index is eventually consistent, and doing what we have done has the interesting side effect, the positive side effect, that we can know if the index is stale or not. If we put data in a totally different storage, really projecting into another document, and we query that storage, maybe on SQL Server, for example, because we like to search on SQL Server, there is no way to know that that storage is out of sync. Maybe is not consistent at the moment of the query. Using this method, we have the statistics that we can output and that can tell us, OK, I've given you some data back, but that data are stale. So we can handle it at the application level, for example, saying to the user that maybe the results are not consistent with what he was expecting. And we'll see in minutes that can be a map reduce. There's the load document API in RavenDB that basically lets you load documents at the indexing time. And if you recall the sample document we had in the first session where we had, for example, the customer key inside the order document, what we can achieve in indexing in indexes is that we can ask the index to load the customer document for us at indexing time, and then we can project into the index more properties of the related customer. Please do not do that. One load document in an index, 19 load documents in the index. It's not the way to go. Okay, it's a pretty cool feature because can solve an interesting problem, but has to be used with care. Then we have transformers. Transformers are there to basically change or enrich the shape of the documents at query time before data are returned to the client. So whenever the document comes from, once it has been loaded by the store, document store, indexing store is not really important. The documents passes through a pipeline where we can put a transformer, just one. Okay? So per query or load, there can be only one transformer in the pipeline. We can put a transformer that as input our document, and as output can have anything we want. So we can totally change the shape of the document inside the transformer. And it's interesting because it runs on the server. So if we have a pretty huge document and we want only to output some properties of the document, we can use a transformer to cut some parts of the document and just return what we need. We can change the shape. And the lovely thing is that we can pass parameters to the transformer in order to try to drive the behavior of the transformer from the client application. So we can have one transformer that can suit more than one scenario, or that can do something more interesting. The Mac is not logging me today. One thing we can do in the application is a really stupid thing that we can select one element and will be sent to another page where we display the data of the element. Obviously, the displayed data here is exactly the same we have seen before, but the shape is not the same. So in the previous screen, we had search result as the class returned to the client. In this case, we have a person view, or what Gianna said, a person view model. It depends on the background you come from. But basically, we have a projection of the person document that is made exactly for this screen. In this case, it's exactly the same as the person document, but it's a demo. But the fact is that what we are doing is leveraging one really, I don't see if, OK, in this demo, I've changed the code half an hour ago. So maybe don't do that. Most of the documents that are living in the current database utilizes guides as primary keys, and because the IDs can be generated offline. Now I've changed the code to use the built-in high-low algorithm of RavenDB. So if we create a new document, we'll see that the new document will have the classical people/1, 2, and 3. Now we have people/id. Okay? One thing really interesting of using the built-in string IDs of RavenDB is that they perfectly maps to a routing engine, like the MVC one or the AngularJS one, and you can just put the ID of the document on the address bar, and it just works. Because what we can do now is that we can define a people controller on the server side, on the web API, and we can accept a string ID, and it works. Effectively, that's what we did. And we have a people controller whose code just do that. Just do this. We open a session, and we go to the session saying, OK, we want to load that ID. And from the RavenDB point of view, it's irrelevant the type of the document that we are going to load. So we are used to say load person. Okay? Because we want to tell to JSON.NET, we want you to deserialize the documents coming into the person class. In this case, we are going to say, OK, we want you to load that identifier that is unique across the whole DB. And we want you to load into a class called personView using that transformer. The transformer is just a class that is stored on the server side and works like indexes, and has just one property that is defined in the constructor. What we are saying is that we are inheriting from the abstract transformer creation task of person, in this case, because person is the document that will flow in from the document store at query time or load time. And we are saying, OK, for each document, just create a new one. And the shape of the new one will be person view. In this case, person and person views has exactly the same shape, but we can do all what we want. We can use a load. Imagine that this document was the order document of the previous demo. And what we can do is here call load document, passing in the customer ID. And we have the customer document back. And we can enrich the order view, adding some new stuff from the customer we have just loaded. So we are basically creating a totally different shape inside the transformer. Why inside the transformer and not inside the index? Because storing document in the index, storing data in the index will enlarge the storage size of the index. So you have different options based on what you want to achieve. There's another thing to take care of. If you have the authorization bundle in place, the authorization bundle is the third coolest stuff I've ever seen on RavenDB that comes from an Hibernate code base, basically, as a concept. You can have security trimmed queries. So basically, you can say from the API level, hey, server, I want to behave as Joe, and I want to issue this query as Joe, and I want you to give me back only the documents that Joe can read, for example, or can delete, or can do whatever you want. It's just a business concept. And without doing anything else, the authorization bundle kicks in, and before the data are returned from the server, the documents that Joe cannot do whatever you want will be dropped from the results. If you store data inside the index, the data stored in the index won't pass that pipeline on the authorization bundle. So there is no security trimmed queries on data stored on the index. In this case, transformers are the way to go, because you pay some performance penalties, but security is a performance penalty from a center point of view. You load the document from the document store, and you pass it to the transformer, and you change the shape. But in this case, you are sure that documents will be passed through the authorization pipeline. And so it basically depends on the scenario. There was a question. Yes, it is the same, exactly. As many as load document we add here, we are. There's a slight difference, and I think you can confirm that is each time you use a load document inside an index, you are basically telling RavenDB, OK, when the loaded document change, refresh this index. So you are saying if you have 5 different load documents in an index that points to 5 different collections, you can touch 6 collections, and if you touch one of these 6 collections, the index will be refreshed, rebuilt from scratch. In this case, you are only paying the performance penalty at query time in this transformer, just that. This is the main difference, and sometimes it is a big difference on what happens. So the transformer is pretty easy. Something that we are. It can be used on top of load or indexes, because the same API that we use on load, we can use the .transform width name of the transformer, and the transformer will be used at query time. The interesting thing of transformers is that they can be reused. So we can design a transformer to be used in more than one scenario to achieve maybe similar results. One other thing I really love is the fact that we can pass we can pass parameters to the transformer, and I don't have a running demo, but I have the code. This is a pretty complex transformer. What we have here is something that we'll see later how it works. This is the projection of an event sourcing stuff. So the data we store in the DB when we do event sourcing is not just events. We need to enrich that data with some infrastructural concepts. So what we store in the end is the concept of commit. And the commit is composed of at least one event, but can be more than one event per commit. But from the user point of view, a commit is meaningless. So what the user wants to see are events, what has happened in the system. And in this case, this is a real code from a real application. In this case, we have the issues that the application is a multi-tenant application where the data are stored and loaded from different time zones. And what we want to do is to be able to, we store everything at the server side using datetime offset. But using just datetime offset, that's why the Matt Johnson session about datetime will be so cool. The datetime offset of the .NET framework is not enough to rebuild the original date time because you miss the time zone. And so you can fall in the situation where you convert to a time missing the fact that there's the solar and legal time. So what we are saying is that we are storing everything as datetime offset, and we are also storing the, over there, time zone. So we are also storing in the documents the time zone the document has been created in. And what the application can do is, OK, I want to load this data, and I want to have the date times converted from the original time zone to this one. If you think to, for example, mail clients, they will never show the original time the mail was sent by me from Italy. They will show the time you received the email. Okay? So what the user wants to say is his point of view of the time. So it just didn't care if it was midday for me. It was 5 a.m. in the morning in the US. That's important, okay? Because it's that time that the user can understand. And so we are, instead of loading data and then iterate on the data from the client side and changing and adapting the data and time, we are doing that in the transformer. From the application point of view, what we do is just, it's a query really similar to the previous one, but we have the transform with. So we are transforming a query result, and we have these two guys, add query input, that basically allows us to add query string parameters on the request that goes to the server. And we say, OK, add the chi and tzi parameters where the C is the current thread culture info. So the current thread of the HTTP request is based on the user choice. And this is the user time zone ID that the user can change in his application settings. So the user, if you have ever used Outlook Web Access asks you where you are now, if it cannot detect from the browser. And on the transformer, we can get back using this .query. We can get back parameters. In this case, I'm using this .query. And now there should be a new overloaded query or default that prevents you from checking for the null value that will automatically. And what I'm doing is just playing .NET code that says, OK, get back the value and convert the current value into the correct time zone requested by the user. So even in this case, I'm using a transformer to change and then reach the shape of the data based on the user scenario and not on the data specifically. So everything like that, but logic that can be driven from the application. Events. In the CQRS paradigm, there is the command query responsibility segregation. We are not currently interested in commands from the demo point of view, but they are the core part of CQRS. So CQRS says that at each command should correspond an event. At each action should correspond something that happens. And each command must generate an event, at least one. Can be more than once. There is no rule on that. Most of the time, there will be more than one event that will be generated from a single command. And The interesting thing is that if we think to events drives our daily living, and so events can drive a system exactly in the same manner. If we have a totally isolated bounded context, we send a command to a specific bounded context saying, create a person. That bounded context says, person created. The search context reacts, and denormalize the search result view of the created person within its database. So if we think at totally separated storage, without using the free feature we have just seen, we can use events to drive the system. We can use events to drive a much more complex system. The user has accepted an order, so just ship it. Okay, it's the shipment context that is living in a totally different way, in a totally different world. One thing really important is that as soon as we introduce eventual consistency and async behavior, we need to be sure that things will happen. So as soon as we introduce async behaviors, we lose transactions. So we basically lose distributed transaction. In our bounded context, transactions are safe. We cannot pretend to have, we cannot expect to have, pretend is in Italian false friend, that has a completely different meaning. We cannot expect to have a distributed transaction across different bounded contexts, because we cannot expect to update a customer and an order on a different database, on a different server that maybe is shut down. So we have to rely on queues. And what we want to rely on is that the queue will guarantee us that that message will be at a center point in time delivered. Or if it won't be delivered, we have a notification back that the message has not been delivered. Okay? So we want to deal with just one issue. That is when things happen, and not if and when. In this case, what can we use RavenDB features with events before seeing what events can be used for, but it's outside of the topic of this session in the end. I've already said that when we store events in an event sourcing system, we are not storing only events. Events carry with them also lots of additional data. For example, when the system has done something that not necessarily correspond to when something has really happened. Who was the user that did something that is not related to the event. The event is order accepted. But who was the user connected to the system that accepted the original order? Maybe it's outside the scope of the event from the business point of view. And we can have a single command that generates more than one event inside a single bounded context. In this case, we want to have the concept of commit, that is what has happened, what has been done by a command, and the commit is an aggregation of event. But since from the point of view of the application, what we are interested in are just events, we want to be able to extract events from commits. If we take a look at the data, every single thing that has happened in the small application that we are using is stored here in this collection called commits. In this collection, there are all the stuff that has happened, and every commit, if I open it, has a list of events. That is an array of things that has happened. The dollar type here is person created. Okay? But from the application point of view, what we want to do is go to the About page and see it's terrible. and see a list of things that has happened, that we have sent the command create new person command, and we had get back the create the person created event. Okay? The user is not interested at all in the commit concept. It's just an infrastructural concept. But we need to find a way to extract those things, and is something that is that perfectly fits CQRS. And we can do that using multimap indexing, even in this case. And here, there we go. So we define a moment type. The moment type represents something that has happened in the system and can be both a command response, a command exception, an event. These are all the things that can happen in the system. And then we add one map, even in this case, per each things we want to map. So we have the commit, and here is the interesting part. This line is the interesting part. So we are extracting the inner collection, and we are projecting out all in the inner collection. From the reader point of view, all the other stuff that are around the list of events are totally irrelevant. So we are using that feature to project stuff out. And then we are doing exactly the same thing as before. We are adding all the documents. And in this case, we are using the store all fields call because we want to project everything from the index. In this case, we are not searching anything. We are just streaming out events to the user. We have a list as an infinite scroll that the user can see what has happened in the application. But on multimap, we can have multimap and radius stuff. So if you think about it, we want to have some statistics about what is happening in the system. So we want to know how many commands has flown in, how many events has flown out. We can think about it as we can denormalize that information. So we can have something reacting to an event saying, OK, I'll update this counter. But then we have to face the problem of distributed counters that are not yet handled. Or we can simply live with MapReduce. That is there basically for that. So on top of that index, we can do something. Unfortunately, you have to do this in two indexes. You cannot just say, you have a map, add also this radius to this. But you have to define the index twice. And we have exactly the same index, where the shape of the data is not the full moment class we have just said, but we have just a moment type that can be command, exception, response, event, and a count. Because that's all we are interested in. And we are saying, we are doing pretty the same thing as before. And we are emitting this interesting thing that the first time I saw it, I didn't realize how it works under the hood. But we are basically saying, OK, this document represents one element in the total count. And we have some other properties, in this case, just one, that is event, command, command response, exception, and so on. And then we have the results. So once you have mapped everything, just iterate once on everything. It does not work like this, but conceptually, it works like this. And group everything by moment type. So now we have stuff grouped, and we ask to the system, OK, please sum for us the count property. So now we have groups where we have the key that is the type of the thing that has happened in the system. And for each key, we have the total count of elements. In the sample, it doesn't exist. I have just it running here. So if we go to the indexes and we say aggregation, and this, OK, here it is. So we had 246 command flowing in, 246 command response, and only 243 events. It means that three commands had failed at the web API application level. It has not been dispatched to the queue. Why? Because in this case, the web API application level does one thing on the command, that is validation of data flowing in. So it takes the command and say, OK, it is not valid. From a business point of view, this request cannot be handled by the system, so drop it. And immediately return an exception to the client application. So what we can do now is saying that we have things flowing in that creates new documents. New documents create the document representing the data and creates also the commit stuff. That commit stuff is automatically dispatched once again on the queue. And what we have here is that we can write something, create. It has rapidly appear a number 1 and something going on right there. That means that the command was flowing on the queue, has been handled by the backend server, and after it has been handled, the backend server pushes an event on the queue, and via SignalR, it will be sent back to the client. What we can do now is a pretty interesting thing that is typical of N-Service Bus in this case, that is the toolkit handling all this communication stuff, and of the distributed concept related to queues, is that we can, no, this is the RavenDB server, is that we can kill the backend, try to create something else, and it just stay there waiting, because the command is in the queue, but there is no one handling it. And as soon as we restart everything back, bug, start new instance, takes a while, blah, 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 blah. Right. Oh, hop, done. Because as soon as the process, the interesting thing is that now we can launch as many as you want of this guy, and have distribute the load across different machines. Because if they are all attached to the same queue, we can distribute the load. Okay? So we have seen that we can extract data from sub-collections using indexes. In this case, so we can project data inside the documents. Imagine like if you want to have a projection that is, even from the business point of view, is a projection of all the products sold in the last 12-month orders. You can extract them directly using a query in an index directly from the order document, because you have a denormalized version of the product inside the order, and it's pretty easy to keep it up there. And we are storing the new shape in the indexes we have. The interesting thing is that there are lots of other RavenDB features that can help you when doing projection, in this case, in the case of read models of CQRS. And these two are the live aggregation features that you can try even on the studio. That basically is we can think about it like, OK, I want to aggregate this data, aggregate by this property, sort by this property, and then give me the average of this property, a sorting of a reporting feature. And faceted query are a really, really powerful thing. If you have ever saw that sidebar on Amazon that say you look for SSDs, and they tell you, OK, we have 10 SSD from Samsung, 3 from Vertex, 3 to, and stuff like that. This type of query done in a relational database is near to impossible. And on a document database such as RavenDB, it's pretty just issue one method call, and that's it, and it works. And this is another read model feature, because I have the products in the database, and I want to read them using a totally different shape. I want to aggregate them in a totally different shape. So we have lots of features that are there to support CQRS out of the box. We do not really need to go in the direction of real different stores. In the end, I think that will go, because lots of the features of an application really must live on different servers, on different databases and stuff like that. So you tend to denormalize a lot of stuff. But in the beginning, or if you are in a small application, this is the way to go, the easiest way to go, because you just write a CQRS-based application, but you don't need to deal with all the problems that CQRS bring with the concept of synchronization and denormalization stuff. Oren has highlighted something that there will be event aggregation. Currently, the only way to have event aggregation in the 2.5 version is to have a trigger on the server that does stuff on events as soon as they arrive. So you can build projection out of events lively in the database, and there will be a really great feature. One really interesting thing, so let me create something else, my name, my wife, that is down there sleeping because what the hell I'm doing here? Okay, and we said that events can drive a system, and I have a SQL Server database query here that looks for all data in a search table on a SQL Server database, okay? And if I refresh it, it's empty. That's it. But if I look, and if the demo works, if I look in the queues, I have this guy that have 7 pending messages. So I have created, while I was trying, 7 different documents, person and companies. And if I now run another project, and if the demo doesn't fail, finished, ending messages. Now, if I refresh the query, I have the created data denormalized in SQL Server using another process running on another server doing totally different stuff that can run async and at a certain point in time will run. So in this case, if we needed to project out stuff, we can use the SQL replication bundle. It's there for that, but the intention was just to show how we can move stuff around and create a denormalized version of some data, even in a totally different storage. This can be a storage on RavenDB itself, maybe on a different server that is there just for queries, okay? And if we now try to create a new data with the process running, it will be pretty sync, but we can shut down once and have it running later. So I'm 4 minutes late. I'm 4 minutes late, and I suppose I told everything I want to tell. So thank you very much again. And if you have some question, let's postpone it to the coffee break so we'll have some rest, everybody, all together.